Hello, my name is Vinson McCready. Today I'll be talking about my predictive model for personal loans, predicting whether a loan will default. But first, a bit about myself. I'm a data scientist with a background in banking and a degree in engineering. I occasionally like going outdoors, but I really just like staying in and gaming. But when I was working as a personal banker, I saw the power that information and data could provide to those individual customers. Now I really enjoy utilizing the additional data that's available and giving some added value, which got me interested in taking a closer look at loan default. So loan default is when someone who takes a loan decides to stop paying on it, which ultimately causes a loss to the lender. So data from one Predictor, the lending club, shows that defaulted loans funded between 2012 and 2017 cost investors over 700 million in lost principal. So for a large lender, this loss is manageable, but after working for a smaller credit union, I've seen how it takes fewer charge-off loans to impact the company's financials. So my goal for this project is to provide a predictive model to assist in decisioning loans based on the information at origination so that a lender can reduce the losses from these defaulted loans. The data set I was working with is data from the lending club. The data includes over 2 million loans, which have over 126 features. The 126 is actually just the ones common between different years, as they were collecting different information throughout the years. Taking a look at this table here, a significant amount of these values were actually missing, and some features were just completely missing depending on the year. So a lot of them still had a lot of valuable information though, and I found that a lot of them could be replaced with a zero or interpolated. For example, a column indicating whether a loan had been open in the last 12 months could be generally indicated with a zero when there was a missing value, as it was just no value to input. It was actually just that there had been none opened. I used scikit-learn's random forest and gradient boosted classifiers to create the predictive models. So because I'm working with an imbalanced data set where most loans would be fully paid, the performance metrics I used to determine performance were precision, recall, and area under the curve of the ROC plot. So results showed relatively low area under the curve, where 0.5 would actually be result of randomly selecting outcomes, but a precision of, and also a precision of 62% seemed pretty low, but there's could be still some added benefit. Of these two models, the gradient boosted was performing better. So using that, I have a confusion matrix here, keeping the threshold at 0.5. So probability of 0.5, a loan being 0.5 would be classified as defaulting. And with that, of the 21,807 loans that actually did default, we only caught 1,066. So our recall is quite low. And 636 are being incorrectly classified as defaulting. So even so, we still be able to convert this into savings, as the cost of a defaulted loan is in the thousands of dollars. And on average for the data set that I had, it was over 8,000. So since we have access to the actual principal and interest paid on each loan, I've created a profit curve using the actual loan data. And the cost matrix here, I wasn't able to input values because the lost interest was varied depending on the loan, as well as the amount that was lost from a default. So I just used every single individual loan, and then whether it was predicted defaulting or paid, assigning it the cost appropriately. So the profit curve that I've created is here, varying with threshold. I can sort of change the sensitivity of the model. So the maximum profit here is going to be achieved with a probability threshold of 0.20. So even a model with low precision can still help to increase profit. However, I'm pretty skeptical of the current results, and I needed to do further research into the data. And one thing that I actually didn't really account for was loans that are still active even after their term. So I didn't realize that many loans long after their term of either 3 or 5 years would still be in a repayment period. So I need to modify the model and account for those, which I did not have time to do at the moment. So future study is to account for those active loans, and possibly, instead of classifying loans into defaulting or not defaulting, instead taking a look at the return on investment. So, and creating a regression model instead, which could be also beneficial just taking from an investment standpoint. But appreciate you stopping by. If you have any questions, feel free to reach out.